You must estimate the mean temperature with the following sample temperatures. Find the 95% confidence interval. Enter your answer as an open interval. That is, we're going to enter our answers like this. We're going to put a number here, comma, number, and wrap that in parentheses. Accurate to 2 decimal places because sample data is reported to 1 decimal place. So if you look at all this sample data, the most decimal places anything has is 1 decimal. So we were given some temperatures. We're asked to estimate the mean temperature. So that tells us that we're going to be using the T distribution. So the first thing I want to do is figure out what is the sample mean here, because in order to create this confidence interval, I need to calculate a margin of error using T, a critical T value, times the standard deviation divided by the square root of n. And then when I have that, I'll create this interval by plugging in x bar minus the margin of error, x bar being the sample mean of all this sample data, and then the upper number will be x bar plus the margin of error that we calculate up here. So I'm going to calculate the mean, I'm going to calculate the standard deviation, and I need to know what n is. But n is pretty easy in this example. I just have to count up how much data. Now the way you want to calculate s and x bar, use a spreadsheet. So let's start there. I'm going to copy all this data into a spreadsheet using Google Sheets. And now I'll put my mean next to this cell, my standard deviation here, my n, that is my sample size. Let's call it sample size. And then I'll also use a spreadsheet to get my T critical value. So to calculate the mean, we're going to use the average function. So I use average function and I drag over all this data, A1 to A10. And then I'll do the same thing here. I'm going to use the stdev.s for sample and drag over all this data. So there's my standard deviation. Now my sample size, I could just count, I could just look here, but if I didn't start at 1 and if I had a lot of data, I could do something like this. I could use the count function. And I'll drag over all this and it should tell me there's 10 there. Now to get the critical value, I need to know what my confidence level is. That is 95%. So that would, on a bell curve, on the T distribution, I'd have 95% in the middle, and that leaves me with 5% for the 2 tails, or 0.025 in each tail. So altogether, this should all add up to 1. So knowing that there is 0.025 in one tail, I'm going to come back to my spreadsheet and use the t.inverse function, t.inv, and I'm going to either plug in 0.025. The problem with this is it will give me the negative, degrees of freedom. It'll give me the negative of my critical T value, but I can simply make it positive and use the positive version. So my degrees of freedom is the 10 minus 1. So I could type 9, or I could click on the cell that has my n, my sample size, and subtract 1. All right, so my critical value is actually the positive 2.26. So if you don't like that, I could look at my bell curve here and realize that to the left of the one I want, so the one it gave me was this one, because this negative number has 0.025 to the left. But I could look over here and say, oh, well, this one has 0.95 plus 0.025 to the left, or 0.975. And I could change this to 0.975. And now I've got the positive critical value. So unnecessary because I know that I can just change it to positive Now, that means I'm going to take all this and get my margin of error. Now remember, the margin of error formula is the critical t-value times the standard deviation divided by the square root of n. So on my spreadsheet, I can say equals the critical t-value times the standard deviation divided by, and I'll use the square root function here, the square root of my sample size. And I have my margin of error. And then finally, I can create the x bar minus e, so the lower number, and then I'll do the same thing for the upper number. So all I have to do here is say equals my x bar, which is my mean, minus e. And down here, I'll say minus my x bar, my mean, plus this time e. And here are the upper and lower numbers. Sorry, I said that backwards. The lower number and the upper number for my interval. So let's use 17.10 and 29.24. So my answer would be 17 point, bad short-term memory, 10 and 29.24 for the upper number.